We present TOHO, a deep learning model that generates natural and continuous task-oriented human-object manipulation motions. Humans are in constant interactions with objects around them, and with different intents of using objects, humans may conduct distinct motions with objects. Generating such sequences has many applications in movies, AR, VR, and video games. Whereas methods were proposed to generate natural human motions, they either only focus on modeling humans, ignoring the object movements and the intent of using them, or only generate manipulation sequences with known objects already attached to the human hands. Furthermore, none of these previous works can generate continuous human motions. Our method, TOHO, is a unified framework that takes a step further toward general human scene interaction simulation, generating complete and continuous human-object interaction motions with novel objects to perform specific tasks. Given three inputs, a task type, an object, and a human pose with its shape at its initial position, our method generates a human motion sequence allowing the virtual human to conduct the task with the object. The pipeline of TOHO consists of 4 stages. Firstly, the object parameter sampler estimates the object's final translation and orientation offset from its initial position, using the human shape, the object's initial position, and the task type. Secondly, the GoNet utilizes the object's initial position and the corresponding calculated object basis point set distances to generate a human pose at the grasping point. It then takes the object's estimated ending translation and the corresponding BPS to generate the ending human pose. By inputting the object at the initial and estimated final positions, the GoNet predicts the grasping and ending poses. Thirdly, the motion in between module infills motion from the initial to the grasping pose and from the grasping to the ending pose respectively. The motion in between module generates continuous motions to infill the keyframes. Finally, we apply the object motion estimation module to output an object motion based on the generated human motion from the grasping to the ending point. We present the qualitative results of our framework. Here, we present generated results of digital humans with divergent shapes using novel objects on scene during training to perform distinct tasks. As our framework generates continuous motions, it is theoretically guaranteed to allow upsampling to arbitrary frame rates. We show the results of upsampling and generated sequences to higher frame rates. Although the model is trained on 64 frames motion sequences only, we demonstrate that it can generate smooth motion sequences even at 512 frames, which is well beyond the training data. Another advantage of our method is that by designing the temporal coordinates, users can generate motions with different velocities at specific parts of the sequence with the same model weights. We show the motions generated with the same trained model but different temporal inputs. TOHO generates complete and continuous human object motions to conduct specific tasks with the task type, the object information, and the starting human pose and position as the only inputs. This work makes the first attempt to synthesize continuous task-oriented human-object interactions, taking a step further toward general human-scene interaction motion generation. Thanks for watching.